Hello everybody. Today's lesson is about bearings. A bearing is an angle. But in the days when sailing ships traveled the oceans of the world, compass bearings were used. They used to measure the angle of direction from north. And we have to know then what are the conditions of bearings. Number one, the bearing is an angle. With this angle, it should be measured from north. Number two, it should be clockwise direction. Number three, when you write the value of the bearing, it should be a three-figure number. Like if the bearing is 30 degrees, for example, you write it 030. And if you didn't write the 0, 1 mark will be cut. Plus, if the value is not exact, you have to round it to 1 decimal place. You are treating the bearing as you treat angles normally according to instructions of CIE. Angles are rounded to 1 decimal place. We have here 3 examples about bearings. One of them is an acute angle, one of them is an obtuse angle, and the other is a reflex angle. To describe it perfectly, you should mention the angle, which is the bearing, and also the distance. For example, the bearing of B from A, B from A, B from A, north at A. So we have to concentrate on the preposition from. The preposition from and the letter that comes after it, it means there is north at this point. And you start measuring from it. Let's say it again. Bearing of B from A, B from A, B from A, north at A. Bearing of D from C, D from C, D from C, north at C. Bearing of P from Q, P from Q, P from Q, say it, north at Q. When you are asked to sketch the bearing of B from A, he will mention also the distance, not only the angle. So the bearing of B from A is 30 degrees, which is 030, and the distance of B from A is 218 kilometers. You have to sketch it nicely. The bearing of D from C is 120 degrees, and the distance of D from C is 730 kilometers. The bearing of P from Q is 320 degrees, and the distance of P from Q is 560 kilometers. Now, there is a lesson which you should know before you go to any example, that the back bearing is. What is the back bearing? For example, if the bearing of B from A, B from A, B from A, north at A, say B from A, B from A, B from A, north at A. If the bearing of B from A is 100, north at A, put your pencil on the north, clockwise direction, watch the arrow. This angle is 100 degrees. And then, what's required? The back bearing, which is you just flip the letters. A from B, A from B, A from B, then north at B. Say A from B, A from B, A from B, north at B. Here we put another north at B. And he needs to know the bearing of A from B. How shall we draw it? Shall we go like that? No, wrong. This is anti-clockwise direction. You put your pencil on the north and you start rotating clockwise direction. How to know this reflex angle? It's easy. Two north lines are parallel. Interior angles add up to 180 degrees. Two north lines are parallel. Interior angles add up to 180 degrees. I'll show you the interior angles. Da 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 da. These two north lines are parallel. And here is the transversal. And this pink angle and that pink angle are supplementary. They add up to 180 degrees. It means you have to find this angle, which is 180 minus 100 equals 80 degrees. Does it look like acute? Yes, it does. Yes, it's a sketch without using compass, without using protractor, sorry, but it should make sense. Now we need to find this bearing of F from B, F from B, F from B, then north at B. Put your pencil on the north, rotate clockwise. How to find it? Oh, it looks like a full pizza and you took the pink slice out of it. So you just subtract 360 degrees minus this 80. It will be 280 degrees. This is how to find the back bearing, and let's go to my workbook. Here, question number 1, there is an order to sketch. From a harbor H, from, oh, the preposition from, then there is a north at H, okay. From a harbor H, the bearing of a ship S is 312, it's a reflex angle. The ship is 3.5 kilometers from the harbor. Draw a sketch to show this information. Label H and S and the length 3.5 kilometers and the angle 312 degrees. Let's go. The first thing I need to sketch is the north. 312, it is above the 270 degrees. And let's name them. He said that there is a harbor H, and this is the ship S, and this is the north direction, and we put the pencil and we rotate clockwise direction. This is 312 degrees. Okay, now we sketched everything except the distance. The distance is how much? It is 3.5 kilometers. This is the distance of the ship from the harbor. Now calculate how far north the ship is of the harbor. North of the harbor. Take care of the language. North of the harbor. So we need here to draw a dotted line like that towards the east from the ship, because east and north form 90 degrees. Now, if we name this angle, no need to name it. I can name it X, for example, and we need to calculate it. This angle X will be how much? Angle X is 360 minus 312. So angle X will be how much? 48. Is it a bearing? Shall I write it like 0.48? No, it's not a bearing. It's anti-clockwise. After finding this, we have to deal with this highlighted triangle. You need to know this side of the triangle, because he wants you to find how far north the ship is from the harbor. It means above it. North means above it. By how many kilometers? Now, I prefer in any type of trigonometry extracting the triangle, because when I extract it, it will be clearer. This distance is 3.5 kilometers, and this distance is, I need to know it, which is, I call it Y. Don't use X, you used it before. And this angle is 48 degrees. What is the relation between the adjacent and the hypotenuse and the 48 degrees? It's cosine. So, so it's cosine, adjacent over hypotenuse. Now let's divide the paper into 2 and write here cosine 48 degrees equals adjacent, which is Y, over hypotenuse, which is 3.5. Now fraction equals fraction, then cross multiplication. Cross multiply and calculate it. Now y equals 3.5 into cosine 48 equals 2.34 kilometers. Next question. It's already drawn, and this is about locations of cities as you see it from an aeroplane or as from satellite, for example. These three countries are, these three cities are Auckland, Gisborne, and Wellington. A plane flies from Auckland to Gisborne on a bearing of 115. Did he? Yes, he showed it already on the diagram. The plane then flies to Wellington. The angle AGW is 63 degrees. Why didn't he write it 063? Because it's not a bearing. It's just an angle in a triangle. This angle is 63 degrees. The first question is calculate the bearing of W from G, W from G, W from G, then north at G. There is already a north at G. So what is the angle? What is the bearing that we need to find? It is W from G. Put your pencil on the north at G and you rotate like this, clockwise direction. First of all, let's remember that two north lines are parallel. Interior angles add up to 180 degrees. So this angle is given 115. You can find its supplement, which is 180 minus 115 is 65 degrees. You have to write all information you got on the diagram. It will be very useful. And to know this bearing, the pink one, this one, as if you have a whole pizza and you took from it two slices. One of them is 63 and the other one is 65. So the bearing equals 360 minus, open brackets, 65 plus 63, close brackets. It will be 232 degrees. It's a three-figure value and it is measured from north, clockwise direction. Now the second question. You have to expect that not all the triangles are right angled. So we are not dealing with Pythagoras nor SOHCAHTOA. Like this triangle, for example. Of course, we have to use then the sine rule that we explained it in previous video. The distance from W to G is 400 kilometers. It is shown here and written. The distance of Auckland to Wellington is 410 kilometers. It's written here and shown. Calculate the bearing of W from A, W from A, W from A, the north at A. Put your pencil on A and rotate. Put your pencil on A and rotate clockwise direction. This is the bearing we need to find, which is W from A, W from A, W from A, the north at A. Put a pencil and rotate clockwise. We need all this green angle. This green angle, it is 115 plus this purple angle theta. If you find the purple angle theta, you just add it to 115. How to find the purple angle theta? Now we are dealing with this dotted triangle. This dotted triangle, we have side over sine equals side over sine. Say it, side over sine equals side over sine. This is dash equals dash. The side opposite to theta is 400 kilometers over sine theta. And the side opposite to the 60 degrees is 410. 410 over sine 63 degrees. And now you sing fraction equals fraction, then cross multiplication. Fraction as fraction, then cross multiplication. Now, sine theta, to make sine theta subject of the formula, sine theta equals a long fraction dash 400 into sine 63 divided by the number connected to the unknown, which is 410. So use the button of the fraction and you write now in the numerator 400 sine 63 close brackets, go down in the denominator and write 410 equals, expect that the sign is positive because all inputs are positive, and expect it should be less than 1. It is 0.8693, 4 decimal places. If you need to find theta, it is sine inverse, so shift sine answer equal. It will be 60.4, 1 decimal place. Is this theta a bearing? No. This theta, 60.4, it is not a bearing. It's the angle which should be added to the 115. So our last step, remember to draw a line with your ruler, and then your last step to find the bearing of W from A. The bearing is 115 plus your answer. Remember that you rounded it. So plus 115 equals, it will be, you write it directly on the answer line, don't repeat it. It is 175.4, 1 decimal place. That's all for today. Thank you. Bye-bye.